We've got actually 3 robots necessary to do the sample and caching system. Our big robotic arm out on the front of the rover, that takes our drill, pushes it against the surface, and allows us to take core samples. Then we put that core sample in the bit carousel, the second robot that takes that from the robot arm and puts it down inside our adaptive caching system. This is the part of the sample and caching system inside the rover. We've got a little tiny robot, a special robot arm called the SHAW, the sample handling arm. It takes the samples out of the bit carousel and moves them through volume assessment, image taking, and eventually to sealing, and then replaces the cylinder containing the sample in a storage spot, all on its own in the matter of a few hours. We have designs on bringing them back in a decade.
8, 7, 6, 5, 4. Engine ignition, 2, 1, 0.
0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas V is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance.
We now have an acquisition of signals, and the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars.